Hi, how's everyone doing? Hi, hungry, I'm Mateo. Did you get pizza in the lounge?
You have a minute. You got more than a minute. Fine.
That actually sounds nice.
Oh.
All right, I'm gonna get speed. All of you. Really good. Love that. I'll be back with pizza.
You ready? You don't look cold. You want to turn on the AC? And you don't look very cold, so do you want me to turn on the AC? No. You're like bundled up, you know? Or did you come from outside, braving the harsh winter, harsh Californian winter?
Hey man, it was foggy.
It was foggy, and it's doing this weird stuff where the stuff falls out of the sky. So dangerous.
No, hold on. People are screaming.
People start screaming.
Distance goes down, and suddenly everybody forgets how to correct.
There we go.
Look at me with the dihydrogen monoxide falls from the sky.
It's crazy. It's crazy. 2, 4, 6, 8, 9. Do you think we get to 11?
Yes. I know for a fact we're not.
All right. So today is a different day. Today is catch up and debugging. Okay. And this is a day where we're not going to be introducing new material, but trying to iron out the things that you don't get. Right. So at the very beginning, I'm going to try and go over some of the broader components. Now, I hope that you are all on the Slack and that you noticed that I wrote a message to you on the Slack and you responded there too. If you're not in the Slack and you don't tell me, you will be missing messages from me. I told you to be on it. It's your responsibility to do that. Okay? I don't use the Discord. Sorry. It's just who I am as a human being. For today, how many people have started the homework? Raise your hand. Good. That's really good. How many people have finished 2.4? Okay. How many people have finished 2.5? Wow. Let's go. How many people have finished 2.9? All right. I was going to get really excited. So we'll talk a little bit about what I expect to see, how I think the homework should look. We'll talk a little bit about how you go from just reading a problem to doing it on your own. I think it's okay to work with other people when you start. It's just not okay to share code. It's not okay to not credit who you're working with if you borrow ideas. I need it to be a communication. Coding looks to you like, okay, I understand how to do it. It's not very complicated. Oh yeah, I wrote different variables, so therefore it's different. No, that will look very obvious to me because the structure will look the same. And I'll say, is this your writing? You'll be like, no, I changed all the V's to L's. Like, all right, that's not you writing code, right? It's practice. So just like the pair programming is practice, this is also practice in you being able to do your own project, because at the end of the semester, you will be expected to do a problem that is not in the book, to create it, to develop it, and then to solve it. Does that make sense? That's where we're headed. Because the major tool that you'll walk away from in this class is an ability to train rocks to think about physical systems. And if you don't see how that's valuable, oh my goodness. Okay. Okay. Anything before we get started? Okay. So one of the first things I want to do is I just want to show you what my code looks like. So I'm going to open up something called Anaconda Navigator, and I'm just going to open up a random thing that I make. It'll take a few seconds here, and I'll just show you how the front matter looks. It's not good code, but I'm also not, I'm not getting graded on it. It's for me, but I'll just show you how it works. So if you haven't downloaded Anaconda for yourself, it looks like this. when you download it. And then I click the Jupyter Notebook. This is just something like you might want to do not in CoCalc. Let's say you want to run your own project. It opens up in the browser and it looks like this. Oh, relax. Okay. So it looks like this. And it actually understands the directory subtree of your entire computer. So these are all my folders. You're familiar with something like documents. And then you have some other stuff that's real nerdy like. And if you scroll down here, you can see, I have all this types of files. So I have something like baseball data mining, right? Because I'm a nerd. Okay. I love pulling data off of the internet and then trying to find like patterns. But let's look at something that I just used yesterday. So of course I can go to when it was last modified, and I can open up something like Zooniverse Uploader. So this is what I use in order to take spacecraft data and upload it so that citizen scientists can interact with it. And you might need to install stuff. Now, you personally won't ever need to install stuff because I'll teach you how to do that. But here's sort of the necessary packages part that I copy and paste to every single object, right? And what you see here is this just reduces how much I have to think. Let me make it bigger for you. So I say necessary packages. I import stuff like matplotlib. So this is how I do my visualization. You have your fun stuff like NumPy. You have date time. So that, for example, tells you stuff about converting from number dates into dates like January 3rd, right? Words. You have stuff like OS. OS is your operating system. That allows me to work with my operating system. Then you have some other stuff here that you probably won't run into. Stuff that is straightforward, like math. You understand what math is? You also have stuff like CSV. That's comma separated values. So that allows me to like work with tables. And you might just keep piling these in, keeping them in one document that gets longer and longer and longer. That's perfectly okay. If you include packages that you don't use, that harms nothing. Okay? And at the bottom here, I might have some specific stuff, right? Now notice what I have here. This is one little import. And then look at this. What's that thing? What? It's a user-defined function. Who created this function? Krismani did. User. Okay, so let's see what it does, right? We're not really going to understand it in the same way because you won't know what we're doing here. But let's see if we can understand it from the black box version. So I call it extract something data, and I give it a file path. So I give it a piece of data, and then what does it do? It returns to me the longitude. Okay? And all of this stuff that happens in here, I don't know. Right? I wrote it. I'll never think about how it works again as long as it works. Okay? And similarly, I have another one here. I had to build a second thing. And so because I'm so good at my job, right? What did I do? I wrote what I was doing. I said, extract the thing and do the thing. And then in here, I even wrote myself a little note. I said, combine orbits into a dictionary. It's like, oh, okay, I'll remember to do that, right? Down here, I say I want to go through all the folders and files. And so this is called definition update file names. So I give it the folder path where the file exists, and I give it the thing that I care about, and I ask it to go through and look for all this stuff. Now look at how beautiful that is. You want to talk about nests? That's a fuck ton of nests, right? Okay, so let's see how many tabs we got here. The first one is def. And all of this lives within def, right? This is tabbed over. And then I have a for loop. So I go through something, I do a bunch of things, right? And then I ask it questions. If this is true, do another for loop. If this is true, if this is true, if this is true, else, else. You see? So I can even have nested if else's. Does that make sense? You don't have to memorize this. I just want to show you the structure of how complex it can get. And every once in a while, you just have a little comment, right? This is something weird. This ensures that it's always 4 characters long. I want to remember why the hell they did that, right? This one here finds the current thing in part of the file name. Good, okay. So you notice that I'm not writing a comment on every single line, but just enough to kind of understand what's going on. Okay. Similarly, I get towards the end, there's no return. Oh no, what happened? Yeah, so essentially what this is doing, I have prints here. These are telling me whether or not something occurred. And what this thing does is it updates the file names. So it goes into my directory and it changes the directory file paths. So let's say there was a mistake with how they were written. It goes in and it literally fixes the name. And so I don't need it to return something. I don't need it to give me back something other than to tell me that it did a good job. I went through all the files you asked me to, and I made sure that they looked right. Right? That's the result I want. But it's not something that I'm going to load into a variable called x and then take times 2, right? That makes sense? As opposed to the first one, which returns a thing that I use. This returns a number that I actually create, right? Good. And then I have some other stuff down here. I might say like, oh, here's this thing. Here's where this stuff lives. Okay. So I will put your definitions and like important parts of, let's say you have a file that you want to read in, and that lives in downloads. Then I can say here, I can say here's where the path to that is. And I say it's not where you are currently in the computer. You have to go look in this folder. Now that's not the right folder, right, for where your downloads are, but it would say something like instead of documents, it'd say downloads, and then it would say the file, right? And you can make these part of your path, because then if you pass it to a friend or you hand it to someone else's computer, all you have to do is comment out yours and then uncomment like your friends, right? And then they can use the same piece of code. Does that make sense? Okay. And look what it does. It does an update. It says, oh, I didn't have to change anything. You're so good at your job, right? We do want to make sure that we have some number of print statements, right? If you have something that's processing, whether it's a for loop, whether it's a user-defined function, because if it takes a long time and you're not sure whether it's running, let it just spit something out every once in a while. Just demonstrate that it's working. Hi, I'm on iteration 1000. Hi, I'm on iteration 2000. Hi, I'm on iteration 3000, right? Something simple just to let you know that it hasn't like hit a snag, right? This is especially true if you have a while loop, because while loops have no end. And if that flag never trips, you'll just run out of CPU time and you'll be like, damn, this calculation taking a long time, and it might not ever be doing the calculation, right? Okay. Questions about this process? Yeah.
Um, if since there's not else statements for all of the
Yeah.
ifs, um, so what happens if, say, like if match is not true? Does it just skip over to the next?
Yeah, so this is looking. So in all the subfolder paths, it says, does this file exist? If it doesn't exist, right? And you just go all the way down here and it says, I didn't find the data. All right? If we go back up one, this if says, okay, well, this orbit is here. It's usually split into multiple files, right? And it says, okay, it's in there. And I'm going to grab one of them. They're all taken at slightly different times, okay? And then it says, make sure that you turn it into a 4 decimal character so that I can compare them. So if it's in there, compare them, and then print, okay, I renamed it, or they were already the same, right? It's in there. I compared them, they either were the same or they weren't. So this if does nothing. Yeah.
Is it because of the else's that you have? That's why you don't need a return for the for like function
Fours never have a return. You mean for the definition?
or definition, sorry.
Yeah. For this one, the process here is just to go through and make changes to the file structuring.
Okay. So it's never like a set, do this.
Yeah. Well, it's doing stuff, but it's never like returning an answer. So I always think of user-defined functions as, okay, I hand you a phone and you hand me money. Or I hand you money and you hand me a phone. That's the simplest way to think about it. But sometimes I hand you money and you go off and maybe clean my yard, right? And I don't see that happening. So that's what's happening here. I hand him money and then the pool gets cleaned, right? It's like reorganizing all my files. It doesn't have to tell me or it doesn't have to like give me back my pool. I want my pool to stay where it is. I just want it to be clean. And so it tells me at the end, yeah, I cleaned the pool, right? That structure makes sense? Okay, so questions, comments, concerns before we move away? Okay, so now let's have a look at what we need to do. Who has finished 210? Who has finished 212? Who has started 212? Do you have a pair partner? How did you start 212 without your pair?
I mean, I think I did.
So we don't work without our friends, right? What's the Pokemon you shouldn't go alone? Is that it? Or is it Zelda? Zelda. All right. You're not supposed to go alone in this class, okay? It's very straight. It's very like, especially when you're working in pair programming, you can feel this strong urge to be like, oh, I know what I'm doing. And you just start working. You're being the rider and the driver and the navigator. Resist that urge. Okay. I know in particular, certain folks are going to have a trouble with this. And on the other side, some folks are going to feel like, well, if he wants to do it, I'll just let him do it, you know? Resist that urge. You need to stay engaged in the pair programming to understand what the other person is asking for, even if you feel like you don't get it. And in particular, if you don't get it, raise your hand. If I'm scary, Sarah's here. If Sarah's scary, I'm here. Wait, that doesn't work. You know what I mean, right? So my goal in this class is to get you to succeed. I want everyone in this class to get A's. How do you not get an A in this class? Not asking how to do stuff, assuming you know it all already, just trying to demonstrate how smart you are. That's not how learning works. This is not performative. The only person here that you need to perform for is you. You need to learn. So you need to learn how to challenge yourself. You need to learn where you can grow. Okay? That can be listening. Sometimes you're typing, and you're not listening to what the person's saying, right? Because you're like, I think I know how to do this, right? Or like, I should only be the navigator because I always know what to do. It's like, just wait a second. You might learn something new. Okay? Okay. So let's think about how we go from our work, the problem that we're presented with, to code. And we're going to talk about not necessarily formalizing this, but I'm going to show you a demonstration. So let's go to 2 point, let's go to 2 point, where'd it go, 12? Oh God, this is so zoomed. Ugh. There's binomial, okay. Prime numbers. Okay, what's a prime number? Yeah, what was that?
Divisible by itself.
Okay. It's only divisible by itself or one. So its factors include no other factors than one and itself. What's an example?
10.
Good. One, good. That's the sneaky one. Is 0 prime? Made you think about that for a little bit, right? Is -3 prime? It is in fact prime. It's negative prime. Right? Now, of course, really you should respond with, well, it's not quite Krismani. That's a bad way to state it because it's a -1 that you're dividing by 3. All right, fine. You're right. Well, So 1, 2. How many even prime numbers are there? 1. What is it? 2. Good. What's the next prime? 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 Good. Someone write that down? Because that's the test that we're going to use to create the prime numbers. What's the largest prime you know? Excuse me? Is 97 prime? How would we know? Okay, so let's figure out how we're going to do this problem. This problem says that the example in 2.8 is not an efficient way of calculating prime numbers. And I, tasked with my rocks, am going to calculate a bunch of primes. Okay? Primes are very useful. They're useful not just for mathematicians, but they're useful in cryptography. They're great for understanding like different aspects of applied physics. So sometimes you just need your primes, right? Okay, so we have a couple rules. And we're going to use these rules to develop a faster program for making use of the following observations. These are things that we understand about primes. So we said by definition that primes are only divisible by themselves and 1. So a number n is prime if it has no prime factors less than n. So you only need to check if it's divisible by other primes. Okay, so how would I turn that into code? Another number of times a given prime. Okay. Say that again? What does it mean to be divisible on your computer? What's that? Remainder 0. That's a very interesting word. Is there an operation modulo? So what does 5 modulo 2 give you? What the fuck is the eraser? Sorry, what was that one? 1. Okay. So if I go in here and I say, where's the chalk? God damn it. What a world. What a time to be alive. I know, but where's the good chalk? There's plenty of chalk. There's no shit chalk. You know how to talk to that? Huh? Yeah, all right. If it breaks, it breaks. There we go. All right. All right. 5, 2. What's the symbol? How do I make the computer do it? Double equal? No. Double equal is what?
2%.
Hold on. What is double equal first? Checks if the left and the right are equal. So double equal means are you equal? Single equal means you are equal. Okay. All right. 5 what? 2. 5% 2. Good. So this is modulo. And this tells me that I get 1. Okay. So for something to be divisible in your computer, I need it to be okay, let's break this down. So you want the answer to be 0. So let's start at the answer. We want to compare it to n. Yeah, so some number. And then let's say whether it's divisible by what? 2? So let's say some number n modulo 2 equal. So what statement have I written?
Is the modulus 2 equals 0 for that.
Good. And what would be a way of saying that like in English?
N mod 2 is going to 0.
Okay, you're still saying mod, and I wouldn't say that in English usually. Are you divisible by 2? What's another way of saying that? Are you even? Right? Good. Now we're learning words good, right? Okay. So what about the next one? That one's a little trickier, right? It's no longer as simple as saying, are you even? It's saying,
Are you treated?
are you That's good. That's a pretty good one. Okay, this one is saying, are you divisible by 3? Right? Is that right? Okay. Do I need to check if it's divisible by 4? Why? If it's divisible by 2, it's divisible by 4. Good. So fuck 4. In fact, I can say that to all of the evens. Right? Good. What's the next one?
5.
5. Is it divisible by 5? Right? So what am I doing on the board? I'm not really writing code, but I'm going through an algorithm. And I want you to see that this is the way that you write code. Okay? So I have been doing something. I have been changing a number here. And I'm comparing it to my target number. Right? So this is the thing that I'm trying to determine if it's prime. And I'm doing that by comparing it to these numbers. So I have this equal statement. And of course, that's indicating to me that I need an if. Good, right? Because something has to happen. Because what if n, in fact, is not equal to 0? What? That's it? You're done? So let's say n 15, okay? Modulo, let's go back to 2. What's 15 modulo 2? 1. So is 15 prime? No, but we did find out that 15 is not even. Good. So now, what do we have to do? Now we have to go on and we have to change this number so it becomes 3, right? So something was a result of that thing being checked. Okay? So you might think to yourself, okay, I have a flow chart. Okay, and if you are not drawing these before you start working, you are doing yourself a great disservice. Okay? Does that help you? Does help you organize your thoughts on paper or on whiteboards? There's plenty of whiteboards. If you and your team want to grab one, I don't care. Right? I'll even find good chocolate. Okay? So you start with a number. Okay? You ask it if it's even or not. Right? And then what happens? If it's even, throw it out. Not primed. Except for 2. Let's assume that you have 2. Right? 2 will be a special case. We won't start at 2. Okay, then if it's not even, what do? You check more, right? So you say, okay, as long as it's not even, I'm going to check 3, 5, 7, 9, 11, 13. Is there any way to create those numbers? A list, good. And what kind of list? Yeah, increase it by 2, right? So you could have something that goes on and on and on and on, and it increases by 2, what would that process be called?
Iterative?
It's an iterative process. So now I have a choice for 2 loops. Which loop do you want to use? You can use a while loop and you can use a for loop. This is a personal preference, right? You can say, okay, I'm going to check the first 10,000 numbers. That would be a for loop. You could check for it to continue going, checking numbers until it fails. That would be a while loop. Those are personal preferences. But you say, okay, I notice that I need at least some type of loop here to check, right? And then anytime that it fails, it's not prime. Okay? And at the very end, you get to say, if it doesn't fail, right. Does that make sense? Conceptually, flowcharting it? Good. Then we take this, we wrap it in other stuff, we add caveats, we make it more complex, right? This is like the simplest it gets, and then it gets worse, and it gets worse, and it gets worse, and it gets worse, right? Does that make sense? Okay. So I would love for you just to start with example 2.8. Okay. So you find your pair from Monday. No, wait. You finished your pair. So whoever you worked with on Monday, you're not working with. Find a new one for 212, and you're going to start with example 2.8. You're not doing it. Yeah.
For previous questions, we just worry about that later.
Yeah, we'll come back to that later. I just want you to start with this process. We're not going to do the whole code today, but I want you to see how they do 2.8. We're going to start setting up 212, and then we can work on everything as a group. Because I've been droning on for exactly half an hour.